Good morning, good afternoon, good evening, and welcome to the NRIC Tech Talk on our collaborative NRIC siting tool for advanced nuclear development. I first want to start with my apologies. GoToMeeting is having a network issue and their webcams are not working. So for the time being, you're not going to be able to see the speakers, which is really unfortunate because they wanted them to be able to share their faces and their enthusiasm. But hopefully you'll hear it in their voices and we'll still be able to get you all the information that we want to share today. So my name is Ashley Finan. I'm the director of the National Reactor Innovation Center, and I'm going to be introducing and then moderating this event. And I'll repeat that earlier message as folks join, just so that others know about it. So before we begin, I want to just go over a couple items so you know how to participate in today's Tech Talk. For the best experience, we recommend turning off VPN or Citrix connections. And please submit any questions you might have by typing your question into the chat or question section of the control panel. You can send those questions at any time during the presentation and we'll address them during the question and answer session. If you have any technical issues, please go ahead and email Emily Nichols. Her email address will be in the chat section of the control panel. Emily, if you could add that would be great. Or if you have any programmatic questions, you can also please send an email to nric@inl.gov at any time in the future. This event is going to be recorded and provided on the NRIC website, and your attendance is consent to that recording. And again, for those who have just recently joined, GoToMeeting has a network issue that's preventing us from using our webcams today. So unfortunately, you won't be able to see the speakers, and I apologize for that. But we'll still be able to get you all the information that we're hoping to share today. Just as a little bit of background, the National Reactor Innovation Center was established by the U.S. Department of Energy after authorization of the Nuclear Energy Innovation Capabilities Act, and we work to accelerate the demonstration and deployment of advanced nuclear energy through our mission to inspire stakeholders and the public, to empower innovators, and to deliver successful outcomes through efficient coordination of partners and resources. To achieve that vision of helping innovators move from concept to demonstration and commercial product, we are enabling them to harness the world-class capabilities of the U.S. National Lab System, and also working closely with universities, as you'll see today. To achieve that vision, we're partnering with the private sector, with the national labs and the DOE programs, with agencies and regulators and others to decrease the risks associated with new technology and deployment, and provide access to capabilities, facilities, and tools essential to the demonstration of these technologies. Key to that strategy is looking at the siting of advanced nuclear power and how advanced nuclear energy interacts with society. This is an area where nuclear has not always been successful in its interactions with society and in how we choose sites, and we've seen in the past some failed projects due to poor siting planning and poor engagement. As we look forward, we see an opportunity with advanced technologies to site in a much broader range of potential sites. So we have smaller reactors and reactors that are suited to industrial applications and hydrogen production, transportation support, things like that, data centers. So a lot of opportunity to think differently and to think more expansively about how we site these projects. And there's also a lot of important opportunity to think about how these projects will affect the communities around them. So the tool that you're going to learn about today is the siting tool for advanced nuclear development, STAND. And I really like that name because it makes me think about what we stand for. And at NRIC, we really stand for our vision of reestablishing U.S. global energy leadership and providing abundant clean energy in the future. As we do that, we want to make sure that we also stand for communities and equity and environmental justice, and and really doing things right this time around. So I am very excited about this tool and sharing it with you because it really brings together a lot of what we stand for. And we also see opportunities, as you'll hear, as we move forward, to expand it in the future, to incorporate more of what we stand for, and to incorporate more environmental justice aspects and characteristics and things like that. So there's a lot, and we're really interested in your feedback as well. There's a lot of opportunity here to provide us feedback on next steps. So today we'll have the experts who have been developing this tool speak about it and explain it to you, and then subsequently we'll have some small group trainings next month in February. So if you're interested in actually using this tool and getting hands-on experience with it, that'll be the opportunity to have an expert walk you through the use of the tool. But now I'll go ahead and introduce the speakers. So the speakers' biographies can be found on the NRIC website. Their roles in this project are Matthew Buckner at Argonne National Lab, serves as the project coordinator. Gabrielle Housley from the University of Michigan is the project tool developer. Randy Bells from Oak Ridge National Laboratory performed much of the siting analysis, and Michael Samsa from Argonne National Laboratory is the decision analyst on the project. This was a two-phase effort. It started with taking a look at a number of different sites across the country and developing a method to compare those sites using Oak Ridge tools, University of Michigan tools, and then Argonne National Lab really pulling that together in a decision analysis tool. And out of that, we moved to this stand tool that is able to look at any site around the country with some constraints that we're working to address, but really a very versatile tool for innovators to use or for communities to use. And so with that, I'll let the experts talk you through how the tool works and how it might be useful to you. And I really appreciate folks joining today. Again, for those who have joined since the beginning, GoToMeeting is having a network issue and we don't have webcams available right now. If we're able to turn them on midway through, that'll be great, but we don't have a fix to that because it is a GoToMeeting network issue. So with that, I will go ahead and thank you again. Again, put questions in the chat and we'll address them during the Q&A, and I'll hand it over to Matthew Buckner to give us an overview of the stand tool.
Thanks, Ashley, and thanks again for everyone joining us today to talk about the siting tool for advanced nuclear development, STAND. I'm going to discuss STAND at a high level and then hand off to other members of the technical team that will provide more details about the tool itself and a walkthrough of it. The first thing I'd like to discuss is the question, what is STAND? I have the definition here. It's an integrated tool used to help identify and compare siting locations inside the U.S. for advanced nuclear facilities based on factors related to socioeconomics, proximity, and safety. Essentially, it's a tool to help answer the question, where? Where do I want to site my facility? And along with answering that question of where is exploring the reasoning for why there? What's the basis for that decision? Why that site? Next slide, please. So STAND provides a systematic way based on user priorities and preferences to discover areas of the country that may be good locations to build a advanced nuclear facility. And that this first step is really looking at the US at the state level or county level, sort of a zoomed out view. Next, you go into exploring those areas that you've identified to look at specific sites. And finally, comparing those specific sites that have been identified to develop an optimal option for your facility. Next slide. The factors that STAND currently considers are broken down into three categories, which are defined here. I'll give some examples of each one. The first is socioeconomic factors, which includes things such as like nuclear sentiment in a given area, local construction and labor rates, electric energy prices. Factors like that would fall into this category. The second category is proximity, which includes factors such as distances to infrastructure that may be needed to help support operations or construction, things like major roadways, rail transport, waterways, electrical transmission systems. But it also includes proximity to other nuclear R&D facilities that may be useful or needed to help support your operations. Things like locations of national laboratories or universities that have programs or equipment that may be useful to you. The final category is safety, which has factors tied to regulatory guidelines. These are things like distances to fault lines, ground acceleration factors, floodplain and landslide hazard considerations, things like that would fall into the safety category. And you'll hear more later in this presentation about how these factors, because they're obviously very different factors, how the different factors in different categories can be weighted and the priorities and preferences of the user for each can be compared to one another. Next slide, please. So I actually covered a little bit of this, but I wanted to give a brief overview of the timeline for the development of STAND, which is shown here. As she mentioned, phase 1 began in 2020 with a demonstration of the effectiveness of using individual tools separately. So these were the individual tools at the different organizations. We use them separately. These tools have now been integrated, excuse me, into STAND. For the demonstration, sites around the US were selected, analyzed, and compared for example case scenarios of priorities and preferences. And the demonstration of those individual sites using our tools separately was documented in a publicly available report, which I provided a link for here. I'd note that I think the plan is to provide a copy of these slides on the same site you registered for this tech talk. So if you're interested in the report, you'll be able to access the link once the slides have been uploaded there. So that was phase 1. Next, we went on the timeline, we go to phase 2, which began last year and focused on integrated tool development, integrating all the individual data and softwares that have been used separately in phase 1 into a single tool. In parallel to that development, we also interacted with social science academics during this phase, select industry members, to ensure that the factors that we were considering in our tools in the 3 categories I described on the previous slide were appropriate, that we weren't overlooking any important factors for which data are available. Following phase 2, the testing phase of STAND was initiated. In this phase, both internal testing of the tool by the technical team as well as external beta testing was conducted, and any issues or bugs identified were resolved. And that brings us to where we are this month with the release of STAND and this tech talk today. I'd like to mention, as Ashley noted, you'll hear more later in the presentation about training sessions that'll be planned and organized in the near future next month, based on potential feedback we get from you and others following this talk. So please pay attention later in the presentation for information on those. The final entry on the timeline is, possible development of STAND. Where does the tool go from here? Future work has been identified that focuses on expansion of the tool to include more areas outside the continental US, and that potential scope will be discussed later. But also there's potential development in the areas of just providing updates and improvements based on the feedback we get from users once people start using the tool. Next slide, please. I'd just like to take a minute to acknowledge the current organizations, the team members of the STAND Development Project team and their roles for each organization, which are provided here. NRIC is responsible for overall project management for STAND. The University of Michigan is the lead for integrated tool development, essentially putting all the data and individual tools together and developing the interface for what is STAND. Oak Ridge National Laboratory is responsible for ORSAGE integration. If you aren't familiar with ORSAGE, you'll hear more about it later in this presentation. And finally, Argonne is responsible for project coordination as well as development and integration of the comparison models that are currently using the tool, and you'll hear more about those later in the presentation as well. And with that, I'd like to hand off the presentation to Gabrielle, who will introduce us to STAND.
Thank you, Matthew. As mentioned by Matthew, the STAND application has several different paths that can be used to traverse the application. These paths are site discovery, site exploration, and site comparison. The paths are interrelated and can be approached as a full process or a variable start point based on use case. Users can identify counties in site discovery, which connects to site exploration by zooming to those saved counties. From there, you can view safety, proximity, and infrastructure data to identify exact coordinates of interest and drop those points. These site locations are input into site comparison to run a comparative analysis across the selected sites. This structure is visible in the STAND landing page shown here. The user would start at site discovery if they would like to identify broad areas of interest, such as states and counties for advanced nuclear technology. The user would start at site exploration if they had already identified a general area for deployment, but would like to explore additional contextual layers or drop points. The user would start at site comparison if they have identified site coordinates for deployment and would like to conduct a comparative analysis across those locations. The goal with the STAND tool is to not just provide valuable information, but also to provide it in a user-friendly format. This is visible throughout the design. We provide several guideposts along the way to support the user in their exploration and provide key guidance throughout the application, such as page-level information boxes, indicator-level information boxes, and reference maps. Page-level tooltips are usually located in the upper right-hand corner of the application. These explain the overall process and instructions for the page. Here's an example of a page-level tooltip. Page-level tooltips explain all of the available actions and features of the page in a step-by-step guide for usage as shown. Indicator-level tooltips are small eye icons directly next to the indicators. The information boxes contain the following: an overall description of the indicator, why it matters for additional context, references which are hyperlinks to the underlying reference material, and date of most recent data update or availability as seen in the example here. Reference maps provide additional geographic and comparative context for each indicator. This indicator is focused on generator retirement. This would be useful if you are looking at a replacement scenario such as coal to SMR. Users can identify which technology you are interested in for replacement as well as the time frame. However, maybe you would also like an understanding of what and where retirements are happening generally before you make that decision. When the user clicks on the View Generator Retirement map, a new window pops up. This map shows you the count of generator retirements in each county in the US. There is also additional level of data. Here I clicked on Washtenaw County, home of University of Michigan. Another window will pop up which lists the retiring facility, the technology, and its nameplate capacity is shown. Here's another example of the embedded content of reference maps that are found throughout the application. Here we are looking at the nuclear sentiment reference map. This map shows the estimated percentage of population in each county that supports the siting of a new reactor. If you click on a county, a new pop-up window is shown that shows you the support for new reactors as well as 2 additional related data values, perceived risk and perceived benefits. This chart can also be exported into a variety of image formats. Now that we have covered the overview of the tool and some of the consistent features, I would like to dig in a little deeper into the functionality of the application for the decision-making process. Earlier, I showed you the above slide to explain the different paths of the application based on the use case. We are going to start with site discovery and progress through the application as we refine our considered sites. You would start here if you wanted to identify counties or states that may be candidates for advanced nuclear technology. There are 2 steps to site discovery: setting priorities and county analysis. In site discovery, set priorities, you will fill out a questionnaire to indicate the relative importance of each of the parameters displayed. A few examples of these parameters include state restrictions on nuclear development, energy price, nuclear sentiment, utilities with nuclear experience, market regulation, and labor rates. Here, the user can also review indicator level and page level information boxes, as well as reference maps for each indicator. Once completed, the user can submit and proceed to county analysis. County analysis displays a national priority match map and a top match leaderboard calculated from user inputs gathered in the priority questionnaire. The top matches can also be sorted using the rank, county name, or state name with multi-level sorting support. Users can explore the priority match map by clicking on any county in the map to display a scorecard, save a county for site exploration, or download a report. Here I am using Washtenaw County again. The scorecard will display all of the relevant information for a given county based on the user's priority questionnaire. Click Download County Report to generate a full report for that county. Here is an example of a report for Washtenaw County, Michigan. The report shows additional data for all of the inputs gathered in the priority questionnaire. At this point, the user has worked through the site discovery path. They chose a few counties to save that they might be interested in, but they want more information and would like to refine their search area to a smaller geographic location than a county. The user can then move directly to site exploration. From there, they can zoom to a county, view additional data layers, and or drop points, which are XY coordinates for site comparison. The user can also connect to site exploration from site comparison to add or review site coordinates using a map. In site exploration, users can select saved counties that were saved during the site discovery to zoom the map to that location, or they can use the standard web GIS navigation. The layers drawer on the left-hand side of the screen allows the users to visualize different parameters on the map. For example, a user may want to locate in Teton County, as close to a substation, shown here as green, but not located on an American Indian reservation, shown in red. There are over 50 different layers to explore across the 3 subcategories of proximity, safety, and reference. This includes regulatory data such as population, slope, and floodplains, infrastructure data such as roads, facilities, substations and transmission lines, and also includes protected land, hazardous facilities, and energy-intensive facilities. Here's another example of the layers in site exploration and additional capabilities. In this example, we are looking at the facilities and transmission layer simultaneously. For the base map, we chose satellite imagery instead of street map view. The map key is visible under the layer name in the layer drawer. The facilities are dual symbolized with the size of the circle representing the nameplate capacity and the color representing the energy source. The transmission lines are symbolized in green. This icon informs the user that they can click on the layer to display additional information. Clicking in the map will show you additional information on electric energy generators located at that point. Switch to the Transmission Lines tab to show additional information on the transmission lines also present at that location. Many of the layers for site exploration as well as site comparison were contributed by Oak Ridge National Lab's OR Sage. Randy Bell from Oak Ridge National Lab will now discuss the contribution of OR Sage to the STAND tool.
Thanks, Gabrielle. My colleague, Dr. Femi Tamu, and I have been working on the development of our ORSAGE siting process tool, along with many other contributors, since 2008. ORSAGE uses industry-accepted parameters for screening power plants, our power plant sites, enhanced by a wide array of GIS data and spatial modeling capabilities at Oak Ridge National Lab. ORSAGE adapts the 10 CFR 100 reactor siting regulations through the application of Regulatory Guide 4.7 guidance and EPRI siting guidance. We use approximately 50 data sets to reflect the 1.8 billion acres in the contiguous United States into 100 meter by 100 meter grid cells. The process of assembling the data layers and exercising a search query for the 700 million cell visual database is shown in the upper right on this slide. Next slide, please. This slide demonstrates the output from a typical ORSAGE search query. The visual result indicates promising results as well as parameter flags. The map scale can be national, as shown in this slide, or it can be regional or local. And the individual results can be interrogated actually cell by cell to reveal what parameter flags may exist for that cell. This slide lists the screening parameters provided to STAND by the ORSAGE tool to inform plant siting in the exploration and comparison phases. Where possible, a range of parameter values shown in the red text are offered for investigation. Population data selection offers a choice of current data or a 2030 projection as well. In addition, the sublayers that make up a roll-up layer can be investigated separately within STAND. Next slide. In the exploration phase of STAND, ORSAGE siting parameters can be explored as desired, as Gabby had shown earlier. Only the parameters of interest need be activated. In the comparison phase of STAND, users can compare sites of interest by attributing a weight value for their technology with regard to the ORSAGE parameters and other STAND parameters, as will be discussed later. Back to you, Gabrielle.
Thank you, Randy. Site comparison has additional capabilities beyond viewing layer data. Click the Add Sites icon on the right side of the map frame to add sites. If a new site is added, a dialog box will appear. Input the name of the site and submit by clicking Save to List. Once the sites have been added, the site will appear in the Site List drawer. Users can click the blue site name to zoom to that site in the map pane. Once all the sites have been added, the user can click Compare Sites to proceed to site comparison, where all sites added will be automatically displayed. Site comparison uses a multi-objective evaluation model as a structured framework for identifying which proposed sites best maximize the attribute that the user values. Users must provide a minimum of 2 sites and a maximum of 20 sites. These can be uploaded via CSV, typed in manually, or by dropping points in site exploration. Mike Samsa from Argonne National Lab will now provide an overview of the site comparison methodology.
Thanks, Gabrielle. We just mentioned that the site comparison uses a multi-objective framework to help you identify the best overall nuclear technology demonstration site with a set of alternatives that you provide. When looking for a site, you're probably not going to be able to find a location that perfectly matches all of your criteria. You'll need to make some trade-offs, and the site comparison model is designed to help you do this. There are 4 components in the site comparison model. There are objectives, and these are broad categories of things that you want to either maximize or minimize in choosing a demonstration site. There are attributes, and these are physical characteristics that describe how well a site satisfies the objective. These are things like cents per kilowatt hour, miles, whether or not a condition such as a fault line exists, or whether it's present at the site or near the site or not. And then there are value functions. These are used to convert attribute measures, which are in different units, to sort of common currency that we call relative value. These are then weighted and added together as shown in the equation, and the weights are derived from your preferences. Preferences express your views with respect to how important each attribute is in choosing a site, and how significant the difference is among the sites in terms of the value, in terms of the attribute measures. The total value score for each site is then just the sum of the attribute relative values times their weights. Next slide, please. This slide shows the 3 objectives and a partial list of the attributes associated with each one. The socioeconomic objective is to maximize favorable economic, social, and local energy policy factors that may influence acceptance of your demonstration. The proximity objective is to satisfy all environmental and regulatory exclusion zone criteria and to minimize the distance to infrastructure that supports your demonstration. And the safety objective is to meet regulatory guidelines for safety factors or to minimize safety risks by mitigating such hazards. As you can see, there are several attributes associated with each objective, and these attributes have a variety of different units. Next slide, please. The value functions simply convert these attribute measures that are different units to a common unit that can be weighted and added together. We call this common unit relative value. This slide shows examples of several value functions for a specific set of alternative sites. Let's take electricity price, for example. That's the chart in the upper left-hand corner. A high regional energy price is expected to be more advantageous to siting nuclear technology demonstration than a low regional energy price. Among the alternative sites in this example, The highest price is 50.5 cents per kilowatt hour, or I'm sorry, 20.5 cents per kilowatt hour. And the lowest price is 7.8 cents per kilowatt hour. We assign a relative value of 1 to the best price, 20.5 cents, and a relative value of 0 to the worst price, 7.8 cents. All electricity prices that fall between the best and the worst price will have a relative value defined by the straight line between the best value and the worst value case. Similar value functions are constructed for the other types of attributes. Next slide, please. To determine the weight that is applied to each attribute, STAND elicits 2 preferences from you. In each case, you're asked to categorize your preference into one of 6 categories from very high to very low or none. This chart shows the maximum weight associated with each cell in the 6x6 matrix. The first preference along the horizontal dimension is called attribute relevance. This refers to how important or how relevant you think the particular attribute is in selecting a demonstration site. Relevance has to do with how important the attribute is to you, regardless of whether the site performs well or poorly with respect to that attribute. If you don't care about an attribute or if it's not important to you, then you would categorize it as not relevant. Not relevant has a numerical value of 0. Second, along the vertical dimension, you're asked to consider how significant the range is between the best measure and the worst measure of each attribute. And this is based on the alternative sites that you're considering. Ranges of attribute measures that you consider large should be categorized near the high end of the range significance scale and vice versa. If there's no difference between the sites, or if you judge the range to be so small as to be insignificant in your choice between the sites, you should categorize it as not significant. STAND takes your input and calculates a weight for each attribute in the site comparison. As your categorization moves from the upper left in this matrix to the lower right, weighting values decrease. Next slide, please. You saw this diagram at the beginning of the site comparison discussion, and I've covered a lot of detail in the intervening slides. But the important takeaway is that the STAND site comparison is designed to help you identify and make trade-offs among the things that you're looking for in a demonstration site. It's built on 3 primary objectives. There are attributes that describe how well each site meets those objectives. It incorporates preferences on how relevant or important those attributes are to your choice of site, and it considers how significant the differences are among the sites. Next slide. Site comparison takes all of this information and calculates a single measure of merit for each site, as illustrated by the bar charts on this slide. Gabrielle will now show you how the site comparison methodology is implemented within STAND.
Thank you, Michael. The methodology explained by Michael is mirrored in the application. Indicate how relevant or important each attribute is to your choice of an optimum site. Consider how relevant each attribute is without regard to how well or poorly each of your alternative sites perform with respect to the attribute. If you care very little or not at all about an attribute, you can indicate it as not relevant to your choice of sites. Attributes indicated as not relevant will result in a weighting factor of 0. On the left-hand side, click on each objective, socioeconomic, safety, and proximity, to display the attributes for that objective. Users can also make additional parameter level selections where applicable, such as buffer distance, time range, etc. The user then submits the relevance form. The significance form shows the best and worst quantitative measure across all of your alternative sites for each attribute in the preference model. In addition to the best site and worst site measures, other analytics are represented to provide context for your assessment of range significance. Indicate how significant the difference is between the best and worst site measure in your choice of an optimum site for advanced nuclear technology. As an example, assume that a regulatory safety buffer from some installation is 5 miles. All of your alternative sites are between 50 and 100 miles from the nearest installation of this type. Although the difference between the best site and the worst site is 50 miles, they all exceed the threshold by such a great amount that the difference between them is not significant. This AR-RS matrix presents each of the preference model attributes according to the attribute relevance and range significance that you indicated in the previous 2 steps. Also shown are the normalized weight calculated for each of the attributes. Normalized weight sum to 100. The user can review the placement of each attribute within the matrix and its normalized weights relative to all other weights. If desired, users can adjust any of the attributes by going back to either of the previous 2 steps to change the attribute relevance and/or the range significance for any of the attributes. Return here to review the result of any modification that the user makes. When the user is satisfied with the normalized weights, then click Submit to view results. Results can be downloaded in CSV format. This download includes all of the underlying data values, as well as the attribute relevance, range significance, and normalized weights. Graphs can also be downloaded in a selection of image formats. There are also additional graphs that can be displayed beyond the one shown here, such as this graph of normalized weights. Now that we have completed the overview of the tool capabilities, I wanted to pivot to discuss the value and stability of the tool. Beta testing was conducted on stand over a 2-week period in November and December of 2021. There were a total of 13 testers in the testing pool. 12 people took the facilitator guided test and 1 took the user guide test. Each beta tester was tested 1-to-1 with a trained facilitator via video conference. Testers were given a series of tasks to complete. The facilitator provided prompts and took notes. At the end of the beta test, both the tester and the facilitator completed a survey. Beta testers came from a variety of backgrounds, including academics, industry, and policy experts. They also filled a variety of roles within their organizations. Feedback from testing was largely positive. All users were able to complete the task with no or minimal support. All users were also likely to refer the tool to a colleague. This is a common measure in UI/UX design to communicate the value that the tester sees in the tool. We resolved any bugs revealed in the beta testing and also received and implemented additional feedback such as design tweaks, feature adds, and additional documentation where needed. Feedback from users also identified key improvements that could be made in the future to improve the tool. Key improvements suggested by beta testers, which we hope to include going forward, are expanding current coverage of Alaska and Hawaii, adding Puerto Rico, and adding environmental justice indicators such as existing nuclear waste sites, energy burden, and EJ Screen data. EJ Screen is an environmental justice mapping and screening tool created by the EPA. EJ Screen contains a variety of environmental indicators and indexes such as air quality, water quality, proximity to risk management sites, and national priority list sites and hazardous facilities. Thank you all for your interest and attention, and I'm now going to have it back over to Ashley Finan for the wrap-up and questions. Oh, it looks like Stephen Grivkowski might be stepping in.
Yeah,
Take it away,
Steve, sorry, and I'll just apologize. I got a call from a doctor that I had to take, but I got off the call. So I was hoping to punt it to Steve, but anyway, I'm back and I apologize for that. So I hope that you all learned something here. We have some good questions coming in the chat and the question and answer, and we'll move to those in just a minute. Appreciate those. And I just want to let you know, again, I mentioned this at the beginning, we're going to have small group training sessions in mid to late February, where you'll be able to walk through the tool and get your specific questions answered as you go through it. And so for that, if you could please email Emily Nichols if you're interested in being part of one of those sessions, or if you have personnel in your organization who want to be part of one of those trainings. And also go ahead and request access to the STAND tool on the website for this event. And I'll get that website in the chat so that you can remind yourself where it is. I know a few people have requested that access. We will process those just as soon as we're done with this webinar. So that's going to be an opportunity to really walk through it. And I did that with some of our experts, and it was very useful. And I think that if you want to use the tool, I'd recommend engaging in that. So with that, I think I want to thank the speakers very much for those presentations, and we can go ahead to the question and answer portion of the event. So I will pick up some of the questions from the Q&A here. Let me start with, there's a question, is the nameplate capacity in megawatt hours? Do any of the panelists have the answer to that? I'm not sure exactly where that nameplate capacity appeared, but does anyone have an answer to that question?
Yes, I believe they are in megawatt hours, yes.
It should be megawatt thermal or megawatt electric probably. So we'll go back and clarify and make sure it's clear in the tool if that makes sense to the team. Okay. There's the next question is, how are perceived benefit and risk calculated? Is this a survey result? Is sentiment also a survey result? If survey, what is the sample size behind each county roughly? Does anyone want to add to that?
I can address that a little bit. So in the fastest path, we have a whole tool dedicated to that nuclear sentiment data. It was developed in partnership with the Oklahoma University Center for Risk and Resilience, and all of the methodology is available at that web application, and I'm happy to provide the link to that as well.
Great, thank you very much, Gabrielle. The next question is, does STAND allow for site identification, including dry cooling options? And I know that I think Michael or Randy might have had a response to that. I guess Randy did. Randy, do you want to take that one?
Yeah, hi, Ed. This is Randy Bells. One of the parameters we have in STAND is the distance to the nearest cooling water source, and you can prioritize that or not prioritize that as your option requires. So you can optimize it for dry cooling or not. So.
Great, thank you very much. Next question here is, what are the attribute values in the multi-objective optimization from? Are they for current or future systems?
This is Michael. Yeah,
Thanks,
I'm not sure what the last part of that question means, but the attribute values come from the OR-SAGE data and the University of Michigan databases data that you can look at in the discovery and the exploration parts of the model.
Thank you. And if Michael, Craig, if you want to clarify your second part of the question in an additional question, please feel free. The next question here is, does the tool allow developers to explore where industrial or transportation hub siting might make sense? If that is a use the developer is considering exploring, are there specific variables that already speak to those uses, like transmission lines, or ones you think you might add to the STAND tool that speak to those applications of advanced nuclear? So I think a few of these things were shown in some of the layers that Gabby shared, but can anyone on the panel speak to this question at all?
This is Matt. I was going to agree that yes, I think we covered some of the things that they mentioned there, like transmission lines, major roadways, things like that that may end up being indicators of where the hubs would be valuable.
Thank you. And are there any? So are there specific variables that anyone on the team thinks we might add to the STAND tool that speak to those applications of advanced nuclear? I guess I'll just comment from my perspective. We are looking at industrial off-takers a bit more carefully as we look to future development and how we might incorporate those opportunities. But do any of the developers want to comment on that? Gabby, do you want to comment on this one? Okay.
I think I would say that if there are parameters that would be valuable, that there's existing data for. So some of these things that we're interested in, we also, this might be a good thing to know. We don't necessarily have a good data source for or a reliable data source for that's regularly updated and things like that. And so if there are parameters that people are interested in, we can certainly look at adding them as long as we have like reliable data sources for the US and not just for like, one location or something like that. So we're open to any feedback you have. If you have indicators that you think would be good to add to the tool, I'll just say that.
Great, thank you, Matt. Appreciate that. And that's a great point. So folks, please feel free to provide that feedback on what would be useful to you. The next comment is very interesting presentation, but based on UK experience, I would suggest engaging with the local communities as early as possible, rather than showing up with a data analysis that their site looks like a good contender for a nuclear power plant. And yeah, I think thanks for that comment. We did experience a little bit of that in the first phase of this, where we found that we needed to really engage with the sites that we were analyzing before having a final, analysis. Gabby, do you want to comment at all on this and some of the? I guess one challenge here is that we can't actually engage with every community in the country. And we're looking at a countrywide analysis, but as users dig into where their priorities are, it's certainly very, very well taken advice that they need to be engaging with those communities as early as possible, rather than showing up and publishing some result that they're a good community to host their nuclear power plant. So I appreciate that. Are there any comments from the panel on this?
Yeah, I think that's such a good question, and it is really important. This is a screening tool, an initial tool. It does not replace in any way community engagement or community consent. But I think sometimes these decisions are made without looking at how broad the options might be. So this is a way to look at it broadly based on what the user's priorities are, and then the next step would be to engage with those communities.
Thank you, Gabby. The next question here is, how well are isolated communities represented in the existing data, or how well are microreactor use cases captured in this tool? Who would like to comment on that?
So I'll let Gabby talk about the community data. I'm not familiar, Gabby, with the how well minority communities or smaller micro communities are represented in the data.
I believe that the questioner here is talking about remote communities specifically, and the data coverage is pretty comprehensive. I think there could be more indicators that we could build in that are of interest to remote communities specifically, or might more reflect what would make them possibly a good candidate. Another thing I would note is that we have limited coverage in Alaska, which has a high proportion of remote communities, so that's something we would like to expand in the future. And feel free to follow up if that did not fully answer the question.
Yeah, thank you for that question. And I'll note that we are looking to expand to Alaska, as well as some other, isolated in terms of island communities, and so we'd like to do that, funding permitting. That's one of our next priorities. The next comment is, so this is from Adrian Bull, following up on the engagement comment on engaging with local communities as early as possible. So as an addition to that, the nuclear sentiment parameter is likely to be more complex than just a single number. A community can be very positive toward their existing nuclear power plant, but might be very resistant to a new one. Does the tool account for this? Gabby, do you want to speak about the nuclear sentiment data and some of what it does and doesn't capture?
Yes. So again, I'll plug that we do have a tool called Planet that will give you a full methodology of that indicator. So the indicator that we're using as a parameter in this application is support for a new reactor. So that is specifically to a new reactor being built, because you're absolutely right. They might be supportive generally of nuclear, but that doesn't mean they want an additional reactor, especially in their community. We also, in the drill down map, showed you, we also break it across perceived benefit of development or of building a new reactor and perceived risk as well. So we do provide a little additional context there.
Thank you, Gabby. But certainly recognize that there's a lot of nuance there, so appreciate the comment. Next question is there a provision for waste heat usage, for example, heating greenhouses? Does anyone have a response to that question?
This is Randy. I love that question, but the problem is most things in the tool are data driven, and so it's hard to have data on those kind of waste heat usage opportunities.
Thanks, Randy. Does anyone else have a further comment? Okay, I think that where we have, we should take a note here that this is an application that's of interest, and maybe there are data. I know that there's been a lot of interest in waste heat usage, and so increasingly there might become data for these things as we move forward that we can incorporate. So I think that came up earlier, the key, I think it was Matthew who stated that if there are reliable data on a metric or some data source that you want to use, then it's straightforward to incorporate it. A lot of times the challenge is finding the data. Does the policy metric capture statewide new build moratoriums? Gabby, will you comment on that?
Yes, it does. And not just moratoriums, but it also breaks it apart by different sorts of requirements, like a voter approval, legislative approval. So you can weigh each of those individually. So for example, maybe you want to avoid a moratorium, but you might feel that you can overcome some other hurdle. So we do allow for that in the application.
Thank you, Gabby. And then the final question that's in here for now, so if you have any further questions, please do enter them. The last question here is, does the tool identify whether a site is greenfield, brownfield, etc.? Does anyone on the team have a response to that question?
It does not currently, but I think that would be an excellent thing to add, and hopefully we'll do that going forward. It's a very good comment.
Great, thank you. Well, I have a couple other questions that I can ask. And if you have more, okay, I joined the call about 15 minutes late. So there's another question I'm gonna read. I apologize if you've addressed this. Do you view this tool as suitable for supporting an NRC license applicant's NEPA or Part 51 required alternative sites analysis as presented in the applicant's environmental report and discussed in NRC's EIS? If so, how easy or difficult would it be for an applicant to describe the tool's input and output in narrative format? Thanks. So those are two questions. One's about whether this could be used to support the NEPA Part 51 alternatives analysis, and the other is more about how well documented is this? How hard would it be to describe the tool's input and output in narrative format? So I think perhaps I suggest that we start with Randy. Do you have thoughts on the first part of that question? And then maybe I'd ask Gabby or Michael on the second part of that question.
But you know, at a very high level, I think it could inform the Part 51 analysis, but in no way do I think it would be, you know, satisfactory evidence for the NRC to consider. You're going to have to dig a little deeper for that information.
Thanks, Randy. And if someone were using this in an application to be part of that kind of analysis, Gabby or Michael, do you have thoughts on how well documented it is and how it can be described in a narrative format?
I am not as familiar with the process of the application to speak on that, but I think the tool is very well documented as far as underlying data sources, when they're updated, where they come from, and how they're compiled. That's something that's really important to us. That's all I can speak to, but maybe someone else can speak more about the regulatory process and requirements.
Gabby, I think that answered my portion of the question, and there's a good amount of user guidance in the tool that folks will see if they log into it. So I think that's where we could start. And if there's feedback that documentation is not sufficient for how users want to use the tool, then we're interested in that feedback, and perhaps we can improve the documentation. But I do think that the team's been very diligent about documenting well. There's another question now. There are many existing heat applications that could be applied using nuclear heat. Does the tool address what heat applications are, where, and what types are near a site? So that would be partially covered in the industrial facilities section. Can somebody on the team comment on, what is covered there and what might not be? Okay, well, if not, maybe
Actually, I'm just trying to remember what all we put in there, but we tried to cover a range of manufacturing type facilities who might have a need for a heat application. Off the top of my head, I can't list everything that we put in there, but we had quite an extensive database of manufacturing facilities. Great,
thank you, Randy. I appreciate that. And Ed, when we get you into the tool, you'll be able to see exactly what those are. And again, happy to try to add facilities where we can find data for them. So those are all the questions, I think. Yeah, and I think we're about out of time here. So I think I'll close there and really want to thank today's speakers for taking the time to present on this tool, and also for your hard work over the last couple of years developing the STAND tool, which at NRIC we're really excited to have available to innovators and others to compare sites, not at a in a way that really reflects their priorities and the characteristics of their technology, so that they can look at sites according to their preferences. Not everybody's looking for the same thing, and this really allows folks to differentiate in that way. So thanks to the team for all your hard work, both the speakers today and the others who haven't been speaking today. And thank you to the audience for your participation. Also to any of you who are beta testers, we really appreciate your taking the time to provide input. These slides and the presentation are going to be posted on the NRIC website, and if you have additional questions, please feel free to send those to nric@inl.gov. And then remember, if you want to sign up for a small group session, to email Emily Nichols by February 4th, and you can go on to the link for the event to request access to the tool. That concludes today's Tech Talk. Again, thank you for your participation, and I hope you have a wonderful